So, in this video, I'm going to go through answering the question, find sine theta and cosine theta. When you're given the double angle cosine of 2 theta, right, is equal to negative 12/13. And then you're told that theta is between 0 and 90 degrees. So what I know from this information is that my angle theta is in quadrant 1. But I'm given a double angle here, cosine of 2 theta. So I need to use an identity. And here's my identities for cosine of 2 theta. It's 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1, or cosine squared theta minus sine squared theta. So first I have to decide which of these three am I going to use. So I don't want to use the one that has both cosine and sine in it. I don't want to use that. So I could use either one of these two. I'm going to go ahead and use the first one. So what I'm going to do is say, okay, they told me that cosine of 2 theta is negative 12/13. So in the place of cosine 2 theta, I'm going to use the identity and say, oh, well, that's 1 minus 2 sine squared theta. All right, so that's equal to negative 12/13. All right, now I'm going to go ahead and solve for sine because I can. I've got one equation and one unknown, so I can do that. So what I want to do here is subtract 1 from both sides, right? So I'm going to have negative 2 sine squared theta equals, well, now I'm going to have negative 12/13 minus 13/13, right, to get it in the right form. So now I finally have negative 2 sine squared theta is negative 25/13. Now, I got to still go ahead and multiply by negative a half, right? So let's go ahead and do that. So let me rewrite what I had up here. Negative 2 sine squared theta is negative 25/13, right? So now I'm going to multiply by negative a half, right? Sorry about that. And so now I'm going to have sine squared theta equals, and here we're going to have negative times a negative is going to give me a positive 25/26, okay? So here, I'm ready to take a square root of both sides. So I'm going to say, all right, I'm going to take the square root of both sides. And here I'm going to get the absolute value of sine theta, right, is equal to, and here I'm going to get square root 25/26, square root 26, but the square root 25 is going to be 5, and then I'll leave this as square root 26. Now, to undo the absolute value, I'm going to have to say plus or minus 5 over square root 26. So here I would not be sure, well, do I take the positive or negative? But we were told that theta is in quadrant 1, and in quadrant 1, sine, which is the y-coordinate, is positive. So is x. X is also positive. In this case, they're both positive. So I'm going to take I'm going to say that sine theta here is positive 5 over square root 26. Now, your book, and almost every book I know, does not like to keep radicals in the denominator. I still have to find cosine theta, so I'm going to work with this form. I find it much easier in the arithmetic. But for the actual answer here of sine theta, I'm going to go ahead and rationalize. So I'm going to have 5 square root 26 over 26. So that's my answer. Sine theta is 5 square root 26 over 26. That's the first part of that. I still now have to find cosine theta. But in working with cosine theta, I'm actually going to use this form right here, 5 over square root 26. I find it easier. So because we were told that theta is in quadrant 1, I'm now going to use a right triangle to represent theta. Since I know something about theta, I know that sine of theta is 5 over square root 26. So let me go ahead and do that. So I'm going to draw a right triangle in quadrant 1. Here's theta. And I know sine of theta is here 5 over square root 26. Now, since that's true, and I know the definition of sine is y over r, that means that y is 5 and r is square root 26. Okay, so I'm going to have here r is square root 26, and here y is 5. So now I need to find x. I still don't know x, but I can use the Pythagorean Theorem, and I can say, well, okay, x squared plus y squared equals r squared, right? So here I have x squared, and this is the reason I left the form here as 5 over square root 26, as opposed to what the book wants, which is 5 square root 26 over 26, because I don't want to square that. It's just a pain. So I'm now going to say, okay, here, y squared, so y is 5, so 5 squared, right? 5. R is square root of 26, so square root of 26 squared. So now I have x squared plus 25 equals 26, and then I'm going to subtract 25 from both sides. I'm going to get x squared is 1. Take the square root. So absolute value of x is 1. And again, I have to answer, is x plus or minus 1? But we know it's in quadrant, the angle's in quadrant 1, which means the x-coordinate's positive, so I know that x is 1. So I have the x-coordinate is now 1, but I have to go back to the definition of cosine, because remember, they're asking me to find sine of theta and cosine of theta, not just the x-coordinate. So I've got to find here, what is cosine of theta? Well, it's the definition x over r. In our case, x is 1, r is square root of 26. And now I have to rationalize it just because the book's like that. And so I'm going to now have square root of 26 over 26. So now what I know is cosine of theta is square root of 26 all over 26. That's my answer for cosine of theta. All right, so I answered this question given the double angle formula for cosine of 2 theta is negative 12 over 13, and theta is in quadrant 1. I have now found sine of theta. That was over here, 5 square root 26 over 26. And I have found cosine of theta to be square root 26 over 26. Thanks so much for listening.